Stand on the southern tip of Spain, and you can clearly see the mountains of Morocco. The Strait of Gibraltar is a mere 14-kilometer gap separating Europe and Africa. Without traffic, you could drive that distance in less than half an hour. This narrow corridor handles a staggering volume of global resources: 33% of all oil and gas, half of all world trade, and 80% of the European Union's electronics, clothing, and automobiles. We know how to cross gaps like this. China's Hong Kong-Zhuhai-Macau Bridge spans 34 miles of open water, over 4 times the distance needed to link Spain and Morocco. We also know how to go beneath the waves. The Channel Tunnel connects the UK and France through 50 kilometers of solid rock, and we've built rail tunnels nearly 900 meters below the Swiss Alps. Yet, despite the massive economic incentives and a century of planning, this specific 14-kilometer stretch remains one of the few places on Earth where 2 massive landmasses refuse to meet. In 1920, German architect Hermann Sergel proposed a solution that bypassed the need for a bridge entirely. He wanted to fuse the continents by draining the Mediterranean Sea. His Project Atlantropa involved a massive hydroelectric dam across the strait to lower the sea level by 660 feet. This would reclaim thousands of square miles of land, physically connecting Europe and Africa. To handle shipping, Sergel designed a series of lock chambers, similar to the ones used in the Panama Canal, to lift and lower giant vessels between the Atlantic and the drained Mediterranean basin. The project collapsed under the weight of its own ambition. Draining the sea would have decimated regional ecosystems, and the billions of dollars required for testing far exceeded the political will of the 1920s. Sergel's death in 1952 effectively ended the era of trying to eliminate the water. Future engineers would have to find a way to live with the strait's unique conditions. The most direct path is the canyon route, a 14-kilometer line between Spain's Punta Canales and Morocco's Punta Sires. But the shortest path hides a massive vertical obstacle. The seafloor here plunges 800 meters deep. For comparison, the UK-France tunnel is only 180 meters. To build a bridge here, every support pillar must stand as tall as 3 Eiffel Towers stacked vertically just to reach the surface. Even if pillars that tall were feasible, there is nothing solid to anchor them to. The seafloor is composed of breccia, a porous, unstable mixture of clay and loose stone that acts more like wet mud than solid bedrock. Above the mud, the water itself is in constant conflict. When the warm Mediterranean meets the cold Atlantic, it creates violent convection currents that swirl through the strait at speeds of 11 kilometers per hour, making stable construction almost impossible. The final geological trap lies beneath the crust. The strait sits directly atop the boundary where the Eurasian and African tectonic plates are constantly grinding against each other. This is an active seismic zone, famous for the 1755 Lisbon earthquake that killed 60,000 people. A minor tremor here could trigger a total structural collapse of any rigid bridge or tunnel. Between the 800-meter depth, the unstable soil, the violent currents, and the constant threat of earthquakes, the shortest route between the continents is structurally unbuildable. Architect Eugene Sui attempted to sidestep these issues with a proposal for a floating bridge that flexes with the currents and ignores the seafloor entirely. However, the 85,000 crore price tag proved too high for either government to justify. Research eventually shifted west to the threshold route. This path is twice as long, at 28 kilometers, but it is significantly shallower and avoids the worst of the deep-sea canyons. The current plan calls for a 3-tunnel railway system built into this longer route. 2 tunnels would carry high-speed trains, cutting the travel time between Casablanca and Madrid from 12 hours to just 5. After decades of failed surveys, the project finally gained technical momentum in 2006. The contract was awarded to Lombardy Engineering, the same firm that built the record-breaking rail tunnels under the Swiss Alps, moving the link from a conceptual dream to a viable engineering plan. Yet, the construction equipment remains silent. While the geological challenges have been mapped and accounted for, the project is currently frozen by diplomatic friction between Spain and Morocco. The standoff focuses on Ceuta and Melilla, 2 territories located physically on the Moroccan coast but controlled by Spain. Morocco considers these areas occupied, while Spain maintains them as strategic gateways to the strait. Every time these territorial disputes flare up, the tunnel project stops. Diplomatic retaliations in 2008 and 2020 instantly halted all joint committees, leaving the blueprints gathered over the last century to collect dust. The world's superpowers continue to push for this link to stabilize global trade, but until Spain and Morocco can resolve their territorial borders, the 14-kilometer gap between Europe and Africa will remain one of the most profitable yet unconquered stretches of water on the planet.